So in this series of videos, we're going to talk about vectors. Before we begin, we need to have some basic terminology or understanding so that we are on the same page. A vector is defined by two characteristics. One is it has a magnitude and the other is it has a direction. Now, when I discuss magnitude, magnitude would be a size or a quantity. Think about magnitude like you would think about an earthquake, where we describe how strong or weak an earthquake is by the magnitude on the Richter scale. Another term you want to understand is scalar. A scalar is where we have some real number. Most of the time we do things like scalar multiplication. That's where I'm going to multiply maybe a matrices or a vector by some real number. And that's what I mean when I say scalar. Now, again, our vectors are defined by not only their magnitude or size, but you also need to think direction. And when I say direction, I mean theta. Okay, so that's why we're studying about it in trig. So, two vectors, when they are labeled, two letters normally are what label a vector. So let's look down here, and when I am here, you can see that I have the vector OP. So I always think of this as more like array, where the vector O is, the initial point is starting here at O, and then the second point represents the terminal point of the vector. And you can see that the vector is moving in this, let's say, upwards direction. Okay, so it has a length and it has a direction. Now going back over here, so we want to look back over here at this figure. Here I have a vector. You can see it has a magnitude or a length, that it has an originating point as well as an ending point, and it has we would call this a numerical value or a length for the vector, the magnitude of the vector. The other way that we would describe the vector is the direction, and the direction is as it appears off of the horizon. So in other words, this vector is 30 degrees off of the horizon, so that's its direction, and then it is 10 for the magnitude. So you have direction and magnitude, and then moving back over here to our vectors, we started out by saying we have a vector that is listed as OP. Well, if I wanted to also describe this vector as a different vector as PO, you can see that this is a totally different vector, because although we have a length or a magnitude which would be equivalent, so both of these appear to have the same magnitude, this vector, PO, is moving in a decreasing or downward fashion. So the vector OP and PO can have the same magnitude but have opposite directions. Another idea we want to understand about our vectors are that the sum of two vectors is also a vector. So I can perform operations on these vectors. In other words, if I have the vector A, I add it to vector B, I end up with this new vector, which is just the result of A plus B. So one vector plus another vector yields a brand new vector. Understand also that vector addition is commutative, so I can switch it around and I would still end up with a totally new vector. Here I have another concept which states that if I have a vector and its negative vector, or vectors that have the same magnitude but are opposite in direction, the result would be 0. And that kind of makes sense, and we call this the zero vector. So those are just some terms that you want to understand before we get into the rest of the information about vectors.